Welcome back, mathematicians. So today's lesson is on equivalent equations. And as a definition for equivalent equations, we want to say that two equations are equivalent if they have the same solution. And we're going to work with both a scale balance to work backwards, saying we know the solution and let's make some equivalent equations. And then we're going to work with two equations and we're going to solve them algebraically, similar to what you've done in 6th grade, and we'll see if they have the same solution or not. So kind of two ways to see if equations are equivalent. So just by this first part, we can see that two equations are equivalent if they have the same solution. So one way to figure that out is if you have two equations and you want to find out if they're equivalent, you can solve each equation and see if you get to the same answer. And so for this example, we're going to see if 3x equals 6 and x plus 4 equals 6 are equivalent equations. And so what we do is we would use our inverse operations to solve for x. So we're kind of looking at what's happening to x and we're undoing that operation. And you'll get more into solving equations in the next section. This one's more about manipulating equations so that they look the same. Okay, but I want to show you a method that you're more familiar with first. So here we have 3x equals 6. So that means x is being multiplied by 3. Okay, so I want to do an inverse operation. An inverse is just another way to say opposite. The opposite of multiplying by 3 is dividing by 3. And you want to show dividing with a fraction bar. Okay. The reason is when you divide by 3, these cancel. And you have x equals 6 divided by 3, which is then 2. So the only way that these two equations can be equivalent is if they both have the same answer for x. So let's go through and solve the second one. Right now, if we look at x, what's happening to it? Well, it's not being multiplied by anything, but we are adding 4 to it. So the opposite of that would be to subtract 4 from both sides. And what I typically like to do, especially with more complex problems, is draw a line to separate the two sides of the equation. It's really helpful, especially if you think of it as a scale balance, which is what you did in the review. But back to this problem, I subtract 4. Positive 4 and negative 4 cancel. You get x equals 6 minus 4 is 2. So even though these two equations didn't look the same, they are equivalent because they have the same answer, right? So they have the same answer. Therefore, they are equivalent. Another way to look at equivalent equations is to work backwards. So let's say that you already know what x is. Right here we figured out that x was 2. So we could say that they were equivalent. Now let's pretend we know what x is. We say x equals 4. And let's just use that. So x equals 4. Okay, now to make an equivalent equation, I want to take this x equals 4, okay, and I want to add something to both sides. So one thing I could do is I could add another x. So an equivalent equation would be if I add x to both of these, I would get 2x equals 4 plus x. And those are both the same because all I've done is I've added x. Okay. Now, Another way I could do it is, let's say that I want to say 2x here, like I'm adding x to both sides. But if I know that x is 4, I can say that, well, let's pretend that it doesn't equal 4 plus x. I know x is 4, let's say it equals 8. And it's still balanced because I haven't changed what x equals. So as long as I'm manipulating the equation on both sides, I can create a bunch of similar equations. So we can do a lot of different things with equations to make them look different, but still keep their value the same. So it's actually kind of fun. You can make really complex problems for your friends to solve, and they can work on solving them. They can give you problems to solve too. So for our last example, we're going to start it with what's called a do and undo chart. And this is just another way to solve equations, but we're actually going to build equivalent equations in this method. And we're going to start with saying that x equals 3. Okay, so it's a 3-column. We have equation, do, and undo, and equation, do, and undo. And because I want them to be equivalent, I'm going to start them both with x equals 3 and x equals 3. So I want them to stay equivalent, but I want them to look different. And what you're going to do is you're going to use the fact that you know x is 3 to start changing the way the equation looks. So one thing I could do is I could add 4. Right. So when I do that, I get x plus 4. And over here, I can do the same thing. Let's have to add 4 again. And you get x plus 4. And for my next step, let's say instead of adding 4, I want to add 3x. So I have x plus 4 plus 3x. And on this side, instead of adding 3x, I'm going to add what x equals. So x is 3. 3 times 3 is 9, so I'm going to add 9. So we get x plus 4 plus 9. Okay, and now as I'm doing this, okay, I can also change the way it equals. So this equals 3. If I added 4, it equals 7. If I add 3x, it equals 7 plus 3x. Okay, over here, if I add 4, again, I get 7. And if I add 9, I get 16. So all of a sudden, I have this equation that looks like this. Right? X plus 4 plus 3x equals 7 plus 3x. And then on the right side, I have x plus 4 plus 9 equals 16. And even though these both look the same, because I added 3x here and I added the actual value here, my equations look different, my answer looks different, but as I start to undo these operations, I'm going to go backwards and get to the same spot where x equals 3. So if I were to undo adding 3x, I would subtract 3x. And then I'd get x plus 4 equals 7. And if I were to do the opposite of adding 4, I would subtract 4. And I'd go back and get x equals 3. And the same over here. The opposite of adding 9 would be to subtract 9. And that would give me x plus 4 equals 7. And the opposite of adding 4 is to subtract 4. And I'd go back to x equals 3. So by doing this, I can get equations on both sides. I can do a lot of different types of equations. And what you're going to be doing in the practice for the textbook is taking a look at two equations, and you're either going to solve them to see if they're equivalent, or you can write them next to each other and see if you can manipulate one so it looks like the other. So that's your next step.